Okay, everybody, this is chapter 2, section 3. This is just an extension of sections 1 and 2 where we're solving for a variable and we're doing inverse operations to be able to solve for a variable. In this case, what we're going to look at is being able to combine like terms before we start really doing anything to solve the problem, all right? So one kind of tip that I can give you is that when you're looking at an equation like what we got right here, so if you could write that one down, typically if you have 3 terms, okay, on one particular side of an equal sign, there's typically going to be something you can put together, unless maybe you got different variables on that one side, okay? But right now we're going to work with the same variable on both sides, or at least on one side, and be able to solve this problem, okay? So what you want to make sure is that one, the variable is the same, so in this case it's x. Later on too, we'll get into maybe the variables have an exponent, so you're going to look at the exponents be the same, but right now we're just sticking with the same thing. They all have a power of 1. So the 5x and the 2x, I can go ahead and put them together. They're both positive, so it makes 7x. I still have a minus 23 over here, and then it equals 5. Okay, so I put some like terms together. Now I've got 2 terms left on the left-hand side. Okay, let me write that a little bit here. Sorry. Trying to squish it in there. I have 2 terms left. All right, so now we're back to the last section where, okay, look at the operation of subtraction. So I want to do the inverse or the opposite. I'm going to add 23. Just makes that go away. You're left with 7x, and 5 and 23 is 28. Okay. And then I can go ahead. This says multiplication, so to undo the multiplication, the inverse is to divide. So divide by the 7. It goes away, and you're left with 4 for x. Okay. All right. So once again, I have 3 terms over here. Okay. I want to make sure that I can probably put 2 together. So I got y's here. So I want to put these together. So being really careful here. We can't make a mistake right off the bat. 3y minus 6y gives me negative 3y. I still have that minus 5 that's right here. Okay. And it equals negative 8. Okay. So once again, I identify the operation in this problem is subtracting 5. So I want to do the opposite. I want to add 5. That's going to go away. You're left with negative 3y, and here I get a negative 3. Okay, now this is where you got to be really careful too. And remember your rules that you've known for a long time. I have to divide because that's a multiplication, but I got to divide by the negative 3. Don't kind of make that minus sign go away. And remember, when you divide, if the signs are the same, you get a positive answer. So those go away. I get positive y. And over here, I got a negative divided by a negative. That's going to be positive answer. 3 divided by 3 is 1. Okay? All right. So what I'd like you to do is to try these 2 on your own. Make sure you show all of your steps. Make sure if you get stuck, go back and look at your notes. You can go ahead and hit pause right now and do these, and then you can hit play again when you're done and see what we get. Okay? Okay, so this first equation, we got a fraction, and we have to learn how to deal with that, not be afraid of dealing with fractions. Okay, sometimes when you get a fraction like that, you got to ask yourself, can I reduce it? And that's asking, does a number go into the number on top and the number on the bottom? So 2 went into both the top and the bottom. It was the biggest number that could. So 2 into 4 twice, and 2 went into 6 3 times. So that's how I reduced it. All right. The other one over here, pretty straightforward question, and you should have got R equals 7. Okay. Okay, if you go ahead and write these down, these ones go back a little bit on what we did in section 1. Like I said, sometimes we have specific rules that we have for problems, and but sometimes if we follow those rules all the time, they might not give me a great question to keep working with. All right. So what I'm trying to say here is that in section 1, we kind of said if there's a number outside the parentheses, you could divide it to both sides. Okay, and that would just kind of make this problem easier. Except that in this case, if I did that, 8 doesn't go into 36 evenly. It's going to give me a fraction. So that means I'm going to have to start this problem with a fraction right off the bat. I don't really want to do that. And it's a negative number 8. The 8's a negative too, so it's going to make my sign negative. I'm going to make some mistakes probably. So I'm going to let you guys know that I don't have to always follow that rule. And it's not really a rule, it's an option. Okay. So in this case, what I would rather do is go ahead and distribute that through first. Okay. And that's only because, like I said, the 8 didn't go into 36 evenly. If it did, I would do it. Okay. And you'll see on the next problem that we can't. So I'm going to distribute that. I'm going to get this. Be careful with your signs. I should get plus 8 equals 36. Okay. I'm going to go ahead and take that 8, the opposite of that, or the inverse of that is to subtract 8. Those go away. Okay, I get that. I'm going to go ahead and divide by negative 16. Okay, so that's going to go away, but it's going to make it a positive x now because it's a negative divided by negative. And I'm going to get negative 28 over 16. I always move the minus sign to the top. Okay, so I ask myself, can something go into both 28 and 16? If you know your times tables well, you'll know that 4 goes into both of these. So 4 goes into 28 7 times, and 4 goes into 16 4 times. Okay. Okay. Now on this one, I got a number outside the parentheses, and so I ask myself, I could divide this by 2, but does 2 go into 8 evenly? And if I know my times tables, it does. So I'm going to go ahead and do that because it goes in evenly, and it might make my problem a little bit easier. These 2's cancel each other out, so you're left with k minus 3. And then over here, 8 divided by 2 gives me 4. Okay. Now, to me, that looks like a really easy problem to solve at this point. Okay. So if it's subtraction, I'm going to add both sides, and I get 7 equals, okay. And you could always flip it around. Okay. You could have flipped it around that way at the very beginning so that k was on the left-hand side. It doesn't matter. It's just, this is the way we're used to seeing it written. Okay? All right. So I'm going to have you guys write these 2 problems down that are here. And if you can go ahead and do those 2 problems, you can go ahead and hit pause, do those problems, and then come on back when you're done, and we'll go over them. Okay? Okay, so there's the 2 problems I did in different ways. Here I distributed first, and I'll be honest with you, I could have divided by a 3. Okay, but I just want to, show you there's 2 different ways to do these problems. Okay, if I distributed it, I didn't divide by 3. So I got P equals 2. Over here on the second one, I did divide by what was outside because 5 does go into 15. Okay, so the 5's basically cancel each other out. I get 2 minus x equals 3. I subtracted 2 because that's a positive 2. And I got negative x equals 1. Now, you cannot leave a variable of negative. So you can either divide by -1 or you can multiply by -1 to change that sign. Okay. I have gotten in the habit of always dividing by -1. Okay. Doesn't matter which way you do it. But my answer now is x equals -1. Okay. So that's how you do those 2 different ways to do the same problem. I could have divided by 3 on this one, and I could have distributed this one. I will get the same answer if I do everything correctly. Okay. All right. So if you go ahead and write these 2 down, these are a little bit different. You're going to have variables on both sides of the equation. I'm going to kind of suggest a particular way to do it. You don't have to. I'm actually going to do this first problem 2 different ways and just kind of show you get the same answer. Okay. Write those 2 down. Okay. 2 trains of thought here. I don't like negative numbers, mostly because I'm a positive person, so I like to have positive numbers. But the biggest thing is that kids with negative numbers and having to multiply and divide by them, we kind of make mistakes a lot. Okay, the chance of making a mistake increases dramatically. So what I try to do is make things positive, and then that way I won't make a mistake, or at least I lessen the chances of making a mistake. So for me to do that, I look and I have to, what I'm having to do here is I have to move all of the variables to one side of the equal sign and all the other numbers to the other. It's called gathering. Okay, so I got to gather the variables to one side, gather the numbers to the other side. So what I do is I look at my 2 variables. Which one's bigger? The 7r is bigger. It's positive 7r, so it's bigger than 5r. So what I'm going to do is I'm going to move the 5r. So I'm going to do, the inverse again. I'm going to subtract it to both sides. Away. Hold on. Okay, I'm going to subtract 5r from both sides. Okay, so those go away. I'm left with a -3 equals 7r minus 5r is 2r plus 9. Okay, I'm going to get rid of the 9 by subtraction. So I get this, and I'm going to divide by 2. That says 2 times r, so to undo it, I'm going to subtract. Divide, and that's going to get me r equals -6. Okay, being careful with your signs again. So remember, those went away, those go away, you're left with what we have. Okay, and we like to write the variable on the left-hand side, so yeah, you can flip it. Okay, now if you'll note, I moved the r's to the right-hand side. A lot of people say you always got to have it to the left. Well, you don't always have to, and you really don't. You can flip things at the very end. It's just the way we write it. It doesn't matter where the variable ends up being, okay? But if you're really, some teachers really kind of want to make you do things kind of their way, they'll always say move it to the left, okay? So let's just do that again. I got 5r minus 3 equals 7r plus 9. So I'm going to ask you to write this one down again, just so you have 2 comparisons and you can see what I'm talking about. So moving everything to the r's to the left-hand side, that's going to make me have to subtract 7r from both sides. It's going to go away. 5r minus 7r is -2r. I got the -3, and it equals the 9 over there on that side. All right. I'm going to go ahead and add 3 to both sides now to do the inverse of -3. So they're going to go away. I'm left with negative 2r. Don't drop that minus sign. Kids will make that mistake too. And now I'm going to divide by negative 2. And this is where mistakes come in. First off, negative divided by negative is positive. They go away. You're left with r. But now I'm dividing positive by a negative. You got to remember, my answer has to be negative if the signs are different, and I get that. Okay, now the variable ended up being on the left-hand side. I got negative 6. You know, I got the same answer over here, doing a different way. I am not going to force you to do it a particular way. I prefer this way because that's my way. I eliminate chances of making some mistakes. Okay, so you pick which way you want to go. I'm not going to tell you which way you need to have it done. Okay, right here I do have to distribute, so that's going to give me this. Okay. I'm going to go ahead and move all the variables to the left-hand side. So I'm going to kind of go against my own kind of rule for me. Okay, plus, all right, so negative 6x plus 4x is negative 2x minus 4 equals, they go away, 4. I'm going to go ahead and add 4, do the inverse. I get negative 2x equals 8. And I'm going to divide by negative 2. Okay, so now you got, whenever you see that, or whenever I see it, I go, okay, be really careful with your signs. So I get this, and I get negative 4. Okay. All right. So lots going on there. Just be careful. These problems take steps, and if we mess up a little sign or something in one of the steps, we've messed the whole problem up. So just got to be careful. Okay. Why don't you guys go ahead and write down these two and go ahead and do them. And then you can hit pause while you're doing the work and then come back and hit play, and I'll have the solutions up. Okay. Okay. So a couple things there with that one. You get a negative 3 here for that first one. That was a pretty straightforward question. The second one, you know, we had a lot of stuff going on here when we got to the end. So I'm dividing, and I got a fraction, and that's a negative 16 over 5. Let me clean that up a little bit for you. Okay. And that's not reducible. There's nothing that goes into both 16 and 5 except for 1. That's not going to help us get a better answer. Okay. All right. So let's do these two. We'll finish off here. These are pretty tricky because there are fractions, but we can do these. Okay. First off, we look at, hey, there's x's on both sides over here. So why don't I go ahead and combine like terms first? So x and x is 2x. Okay. Gather the variables to the same size. So what I'm going to do is I'm going to subtract 3.5x because I'm going to get a fraction here, and I'd rather have my fraction be positive. So these are going to go away. I get negative 4 equals, and then 2x minus 3.5 x is 1/2 x, and and it's still at -6. Okay, I'm going to add 6, so I get 2 equals 1/2 x. Okay, and I'm going to divide by 1/2, which really makes me multiply by the reciprocal over here. Now those go away, and 1/2 times 2 gives me 4 equals x. And, I can flip it. Okay, so get good at those. I'm going to do this one with you really fast too, because 2/3 is kind of a funky fraction to deal with, right? There are no combining like terms. So what I'm going to do is I'm going to subtract 2/3 x from both sides, because 2/3 is smaller than 1x, okay? So that leaves me with 1/3 x minus 5 equals, those go away, 1. Opposite or inverse of -5 is to add 5. Get this. Okay. I'm going to divide by 1/3, but remember that's multiplying by the reciprocal. Okay, so those go away. You're left with x over here on the left, and 6 times 3 is 18. Okay. So there you go. Some tough problems there at the end. We got to be good at them. You can be good at them. Just have some confidence. Okay, and make sure if you got any questions about the notes, go ahead and get a hold of me. All right. Take care.